Hello, Assalamualaikum and good afternoon. So today we are going to continue with the lecture 2 of chapter 7, which is limit 7.1. So we stay in the same subtopic as lecture 1, which is we are focusing on limits. Okay, so the learning outcome of this lesson, at the end of this lesson, students should be able to find the limit of fx as x approach to a divided by limit of gx as x approach to a when both are limit equal to 0. So what we have for this result is 0 over 0. So how do we find the limits for this type of function? Okay, operation between two functions. So let's go. Okay, so if we find that the result of division between the two functions is actually 0 over 0, so what we need to do is to do some modification on the function itself. Okay, so this means that the limit is indeterminate form, then the function need to be both gx and fx need to be simplified by factorization. So this is the modification that we have to do. Okay. F of a equal to 0 means that x minus a is a factor of fx. Okay, so let's say we have x minus a on the top, and then if we substitute the value we get 0, right? Okay, means that x minus a is a factor. So if it's a factor, we can factorize. We do the factorization and simplify by finding the remaining quotient from the factor x minus a. Okay, because we will have remainder 0. So we can apply the polynomial concept in this type of situation. G of a equal to 0 also means that x minus a is a factor of GA. Means that to find the remainder factor, so we know one of it is x minus a, so the remainder here, the same as fx, we can apply the concept we learned in chapter 6. Means that we use the long division. Okay, then the function can be simplified by x minus a. So both will have x minus a. So fx will have x minus a, gx also will have x minus a. So we can eliminate this x minus a. So what remain in the function? We can find it by using the long division. So let's see the example together. So let's say we have find the limit of x squared minus 9 divided by x minus 3. So if we substitute this function with 3 directly to find the limit, okay, what we will have? We will have x 3 squared minus 9 divided by 3 minus 3. So this one is 9 minus 1 equal to 0. 3 minus 3 equal to 0. That's why by substitution we get 0 over 0. So because we have this situation, what we need to do, we have to apply the factorization method. Okay, as x approach to 3, it will get 0 for both numerator and denominator. Means that x minus 3 is the factor, right? So we can factorize both x squared minus 9 and x minus 3 with x minus 3. So the denominator, we have the factor form already, x minus 3. But for x squared minus 9, if you didn't see that this can be factorized, this is quadratic, really simple. You can directly factorize by using your calculator. But if you get a cubic function, so what you can do is to do the long division. So it will be x squared plus 0x minus 9 all divided by x minus 3. So you can do long division if we have x power of 3 or x power of 4, the higher power. Okay, here x, so we get x squared minus 3x. So subtract here, we get minus minus, we will plus 3x minus 9. So to get 3x, we get to multiply by positive 3. So 3x minus 9, subtract, we get 0. So this x squared minus 9 can be represented as x plus 3 multiplied by x minus 3. So here we can see that x minus 3 can be factorized, can be cancelled out. That's why we will have what remain here is x plus 3 only. So then when we substitute the 3 into this function x plus 3, what we get? The limit is actually equal to 6. So if we didn't do the factorization, we will have 0 over 0, which is undefined. So what we need to do is to factorize to simplify the both function fx and gx. So that's all what we need to do. Okay, let's continue with the next example. Find the following limits. So let's say for question 8, limit of x minus 5 over x squared minus 25 all divided by as x approach to 5. So we can see that for A, x squared minus 25, both have a factor of x minus 5. And then we also know that we can factorize x squared minus 25 as x squared minus 5 squared, which is x minus 5, x plus 5. So we have to do factorization. Why? If we substitute 5, we get 0 over 0. We have to show that it is equal to 0 over 0 first. Okay? So directly, if you use substitution, what we get is 0 over 0. Means that we have to do factorization. So factorization, we get x minus 5 divided by x minus 5, x plus 5. So we can cancel out the x minus 5. What's left is 1 over x plus 5. So substitute the value of 5, we get 1 over 10. Right? So 1 over 10 is the answer for this question A. How about question B? So we have negative 2x minus 4 and x cubed plus 2x squared. So we know both have a factor of x minus 2 here, so it will be plus 2. So x plus 2 is the factor. We can factorize out. If we factorize out for the numerator, what we get is, we factorize out negative 2, we will get x plus 2, right? Okay, because we have a common factor of negative and 2 here. Okay, so we have negative 2 of x plus 2. And for the numerator, we can factorize out x squared. If we factorize out x squared, what we will have is x plus 2. Okay, if you didn't see that we can factorize x squared, what we can do is x cubed plus 2x squared plus 0x plus 0 divided by x plus 2. We can get the remaining factor. So here x cubed, we get to multiply by x squared. So x cubed plus 2x squared. Okay, so directly subtract is 0, 0, 0, 0. So stop here means that x plus 2 multiplied by x squared. That's why we have x squared multiplied by x plus 2. So here we can cancel out the x plus 2. What remains is negative 2 over x squared. And then we need to substitute the 2 into the value of x lah. Replace the x with 2, so we get negative 2 over 2, negative 2 square, sorry, it's negative 2 here, negative 2, so we get negative 2 over 4, so negative 1 over 2 is the results for this question. Okay, example 3, find the limit x cubed minus 8 and divide by x squared minus 4. Okay, we know that x minus 2 is a factor. Can we factorize x minus 2 from x cubed minus 8? Yes, you can. How? By applying the long division. Okay? X cubed minus 8 can be factorized by using long division. Apply factor theorem where if PA equal to 0, then x minus 8 is a factor. We can now find the limit by substitution. Okay, because when we substitute the value 2 into this function, 2 cubed minus 8, this is 8 minus 8, which is equal to 0. Means that 2x minus 2 is a factor of x cubed minus 8. The same thing as the denominator, we will get 0 also. 2 squared minus 4 is 0. Okay, if we didn't get 0 for the denominator, we get 0 over 4. This is equivalent to 0. It's not undefined. It's still accessible as 0. But if we get 0 over 0, then it's undefined. So we need to do the substitution. Okay. So for this question, we can apply the long division. So let's do the long division. Okay. So x cubed plus 0x squared plus 0x plus minus 8 divided by x minus 2. Long division, we get x squared multiplied by x squared minus 2x squared. x cubed minus 2x squared. So subtract this one, we get positive of 2x squared. So 2x squared, to get 2x squared, we have to multiply x with 2x. So we get 2x there. 2x squared minus 4x. And then subtract this one, we get positive 4x. So 4x minus 8, we need to multiply by 4. So plus 4, so we get 4x minus 8. So the remainder will be 0 lah. Okay, now we know that x cubed minus 8 can be written as x squared multiplied by x squared plus 2x, x minus 2 multiplied by x squared plus 2x plus 4. This is the divisor, this is the quotient. Px is equal to divisor, quotient plus remainder. But because remainder equal to 0, so divisor multiplied by quotient only. So we rewrite the x cubed minus 8 as x minus 2 of x squared plus 2x plus 4. And then for x squared minus 4, directly we factorize it as x minus 2x plus 2. So we can cancel out the x minus 2 here. What we get is x squared plus 2x plus 4 divided by x plus 2. And substitute the value 2. We will have 4 plus 4 plus 4 is 12 divided by 4, which is equal to 3. Okay? It's actually equal to 0 over 0. Here first we show that it's equal to 0 over 0. But because this is undefined, so we need to do the factorization. Okay? Okay, good. Okay, so for example 4, if f of t equal to 2t squared plus 1, determine the value of limit ft minus f2 as t divided by 2 as ft minus f2 divided by t minus 2 as t approaches to 2. So now, we have the function of ft equal to 2t squared plus 1. So for ft, we just replace with the 2t squared plus 1. But for f2 means that we have to substitute 2 into t. So let's see how we solve for this example. So we replace the ft with 2t squared plus 1. And then for f2, we replace the t by 2. So we have 2 of 2 squared plus 1. So what do we have on the right side? It will be 9. Right? 2t squared plus 1 minus 9 divided by t minus 2. So it's equivalent to 2t squared minus 8 divided by t minus 2. Okay then. So what can we see? Here, we actually can factorize out the 2 first from 2 and 8. So what we have is equal to 2 multiplied by t squared minus 4. And this t squared minus 4 can be factorized into, because if we directly substitute 2 into this one, we will get 0 over 0. So what we need to do, we have to do the factorization. So factorize t squared minus 4, what do we get? Yes, we will get t plus 2 multiplied with t minus 2. So t minus 2 can be cancelled out here. So what remains here is 2 multiplied by t plus 2. So substitute the value of 2, we get 2 multiplied by 2 plus 2 is equal to 8. So this is the answer for this type of question. Okay, so another method to simplify the fx over gx if we get 0 over 0 is by multiplication of conjugate method. Okay, why? Because for this part, we may have square root or surd function. So let's see this type of question. If the solution of the limit for a rational function related to surd using substitution method equal to 0 over 0, then use the multiplication of conjugate method. However, sometimes factorization is also needed in order to simplify the function. So it depends lah. We might use conjugate only or we have to use both of the method. Tips: expand the expression between the surd and its conjugate only, whether in the numerator or in denominator. Do not expand the other expression. So what we need to do is the one with the surd and its conjugate, we expand. The other parts, we don't have to expand. Just leave it like that. So we can later cancel out Okay, remember to apply the a plus b multiplied by a minus b equal to a squared minus b squared to expand a pair of conjugate. Okay, so you won't have to expand for this a multiplied by negative b and b multiplied by a, because it will be cancelled out. Okay, so find the limits of x, square root of x, and then minus 1, and all divided by x minus 1 as x approach to 1. Okay, let's see how do we solve for this one. We cannot factorize, right? Do you know how to factorize this one? No. So because we have third function, so we can apply multiplying the conjugate, the one with third, so we multiply with its conjugate. So we have third in the numerator. So what is the conjugate of square root of x minus 1? Okay, the conjugate is equal to x, square root of x plus 1. So what we need to expand? We need to expand the one with its conjugate, means that we need to conjugate the numerator only. So don't touch the denominator. So expand for this one, what do we have? We will have square root of x square and then 1 square. Square root of x, this is a, this is b, so we just have to square both things. So square root x square and then 1 square. So we get the top one, we will have x minus 1. And then because x minus 1 and we have also x minus 1 at the bottom, we can cancel out here. What's left is 1. So what we have is limit of 1 over square root of x plus 1. And then we can substitute the value of x equal to 1 into the function. We get 1 over square root of 1 plus 1, which is equal to 1 over 2. Okay, so let's continue with the next example. Find the following limits. Limit of square root 3x plus 1 and then minus 1 and all divided by 2x as x approach to 0. So if we substitute the value 0, what we get is 1 minus 1 is 0 and then 0 divided by 0. So because it's 0 by 0, so what we need to do, if we substitute the value, we get 0 over 0. So because we have third, so we apply the simplification, multiplication with its conjugate. Okay, so what is the conjugate of this one? Which one has the third? So we have third at the top, at the numerator. So we need to multiply by its conjugate. So what is the conjugate of square root of 3x plus 1 minus 1? Okay, so we have to change the sign here for the second term, right? It doesn't matter whether the square root is in the front or at the back. So just change the sign for the second term. So it will be square root of 3x plus 1 and then plus with 1. So multiply both at the numerator and denominator. But what we need to expand? We need to expand at the top one. Okay, now we just have to apply a squared minus b squared. So what is our a? A is equal to square root of 3x plus 1. And b is equal to 1. So square both these things. So we get square root of 3x plus 1 square and then minus with 1 square. Okay, so at the top we have 3x plus 1 minus 1. And then plus 1 minus 1 will be eliminated. And then we have 3x over 2x. So dx can be cancelled out. So what we have is actually 3 over 2 multiplied by square root of 3x plus 1 and then plus with 1. Okay, now what we need to do, we just substitute the value of 0 lah. So we have 3 over 2 of square root of 0 plus 1 is 1 plus 1. So 2 multiplied by 2 is 4. So the answer will be 3 over 4. Okay. Okay, right? Simple, right? We just have to expand the one with its conjugate. So, example 7. So, evaluate limits of x minus 7 all over square root of 3x plus 4 all minus 5 as x approach to 7. So, we substitute 7 over in the function. We will get 7, 3, 21 plus 4, 25. 5 minus 5 is 0. So, we get 0 over 0 right here. 7 minus 7 over square root of 25 minus 5. Okay, this is 5. So we get 0 over 0. So we cannot solve for this one. So what we need to do, because we have set, we use the conjugate method. Okay, so multiply with the conjugate because we have set at the denominator, so we have to multiply the denominator, the conjugate of the denominator, which is equal to 3x, square root of 3x plus 4 and plus 5. So what we need to expand? We need to expand the one with its conjugate, which is the denominator. Don't touch the numerator. So expand for this one. What is our a? The a is equal to square root of 3x plus 4 and the b is equal to 5. So it will be 3x plus 4 minus 25. Right? Because 5 squared here, this square root can be cancelled out with square. So we have 3x plus 4 minus 25, which is equal to 3x minus 21. And then we can factorize the 3 out of 3x minus 21. We get x minus 7 multiplied by square root of 3x plus 4 plus 5 and divide by 3 of x minus 7. So x minus 7 can be cancelled out. So we have only set of 3x plus 4 plus 5 divided by 3. So now substitute 7 into the function. We get 7 multiplied by 3 plus 4, 21 plus 4 is 25. Square root of 35 is equal to 5. 5 plus 5 is equal to 10. 10 divided by 3. So the answer is 10 over 3. Okay. Example 8. Okay, the last example. Evaluate the limit of 2 minus third x all over 4 minus x as x approach to 4. So if we substitute the value 4, we get 2 minus 2 over 4 minus 4, which is equal to 0 over 0. Right? Directly 0 over 0. Now, what we need to do, because we have 0 over 0 and we have set in the inside the function, we have to multiply with its conjugate. So what is the conjugate? We have set at the numerator. So what is the conjugate of the numerator? So we change the sign for the second term, which is 2 plus set for x. So multiply both numerator and denominator with 2 plus set x. And then, which one we should expand? Okay, we should expand the numerator because the conjugate here is the numerator conjugate. So expand for the numerator, what we have? A is equal to 2, B is equal to third x. So we have 2 squared minus third x squared. So denominator is 4 minus x multiplied with 2 plus third x. So for the top one, we have 4 minus x. So we can cancel out 4 minus x here with the denominator. So left 1 at the top. So it will be 1 over 2 plus x. Now what we need to do is just substitute the value of 4. So what do we have? We have 1 over 2 plus with set 4. So what is set 4? Set 4 is equal to 2. So 1 over 2 plus 2 is equal to 1 over 4. So the answer here is 1 over 4. Okay, simple, right? So for this lecture, what we need to do is, if we get the division of two functions, the limit of division between two functions, limit of, what happened to my, limit of fx divided by gx as x approach to a, we get 0 over 0. Then we need to apply the factorization if we can, or if we have cert, then we have to multiply by conjugate, the one with the cert. So only these two type of method we can use, or maybe we need to combine both of these method. Okay, so what is the tip? If fx we get 0, means that x minus a is both the factor of fx and gx. So we can find the other terms, the other factor, by using the long division. Okay, long division with x minus a. Okay, so this is for this lecture. So I hope you can try for the tutorial question. So thank you and good day everyone.